Hello and finally welcome to another video on my powered exoskeleton project, which I'm now going to call functional power armour, as it is starting to resemble that now. It has been quite a while since I had a video for this. I have done some armour testing with good results so that I know what this should be able to stop, which it should be able to stop AR-15s in 5.56 NATO when it is complete. But as you can probably tell from looking at it, this is just a foam mock-up. Mainly using cosplay foam. I found that the easiest thing to work with. The main reason for the delay on this update is that I had some medical issues myself. Not an exhaustive list, but that was including having part of my face plated and losing one eye, so that has put me back a couple of months, but we're back on track now. You will also notice that yes, this is my kitchen. Doing the video in here because the garage / workshop isn't very well lit, especially when it's getting dark. Also, it's now got just too big to transport easily to anywhere else that would be better for filming. I'll now go through the design choices that I've made, why the armour is where it is, and what I'm going to do in the future. So starting off, we've got the thickness of the armour. Most of the thickness of all of the armour is around 30mm thick. Through my ballistic testing, that is the thickness that I worked out will be good enough to stop most assault rifles, particularly in 5.56 or 7.62 by 39. The chest plate, however, is thicker. That is probably around 50mm. This is because a goal is to stop the new 6.8mm round that is particularly fast and particularly well penetrating. Now the closest round I found to replicating that is 243 Remington, as that is a similar neck down cartridge to the 6.8. The armour itself is going to be made of mainly composite materials with ceramic layering. I have found this to work really well, which means it will all be turned into moulds from here. There'll probably be a lot of work in the moulds. There is still some finishing off going on here. The reason why, as you can probably see, is mainly held together with gaffer tape on every panel, is because gaffer tape surprisingly can be peeled off really easily, but does have some structural strength to get it all together and to wear it as it is to make sure it fits. I've also decided to go full coverage and to go heavy weight on this. The reason behind this, to me, is for the most impressive thing, especially the prototype, is to have basically what will be 95% frontal coverage and probably 80% on the back. Also, if you design to go heavy, if you have to add extra batteries, bigger motors, any little things that can add up in weight, it doesn't really matter because it's already a heavy design. If you were to take a really lightweight design and then it was, you had to double the amount of batteries to it, you would then be massively increasing the weight. Whereas an extra 10 kilos on this will probably make very little difference when it's done. I have designed it so you'll be able to put it on as one person. It currently doesn't stand up by itself, so it is held up with this plastic frame. In the future it could be held up by something like this, or it could be on a board, or there could be perhaps locking pins on the joints. You could also have the motors lock when they turn on so it stays up vertical. However, things like this I see as unnecessary complications perhaps. In the scheme of things, having a wall that it goes up against in whatever usage it might have isn't a big deal, as long as it isn't taking 3-4 people to put it on. So as for the design itself, we'll start at the top, but we will do the helmet after, because we can get it down and onto a table and actually take a closer look at the ideas behind it. So first up, we've got the pauldrons. It took me quite a while to work out the best way to do it, and in the end I settled on this. This is hinged at the top and it's hinged on the rear, and this allows you to lift it up like that. It means it folds back for getting into it. It also means when you lift up the arm as such, it lifts up with you without getting in the way. Also, these pieces, which will be removable and could be changed, these will protect the neck. What I found when putting it on, even though there isn't a gap there now, when you put it on and you raise your head above, there will be a gap, particularly from the sides. There has to be a gap on the helmet at the sides and the rear, so you can actually lift your head up and look up. Onto the chest plate, you've got basically two main shapes. You've got this flat part that runs up over the shoulders. It still lifts up at the shoulders like the actual exoskeleton itself. That is because all of this does have the exoskeleton underneath, although I will be able to delete most of the exoskeleton because all of these will be structural parts themselves. And while that doesn't actually reduce the weight much, what it does is reduce the manufacturing complexity of building the suit in general. You also have these that are on a hinge. This is just extra armour hanging down from the chest plate. I'm probably going to try a Kevlar hinge and have basically a run of Kevlar that doesn't have glue on it in between two pieces that do and sandwich it together. That should produce a really lightweight, crucially silent hinge that will be very hard to break. These also have angled sides to them. This is so that when they do split out, you do still have a degree of coverage in between the gaps. And this is a centre waist belt. This sits in the middle, it's attached to the spine at the back, so it does stay there. And it's the same type of thing. You still have the coverage there that falls down and goes under the protection for the waist. This does rotate freely and it opens from the side, allowing you to get in. Which brings us down to the groin protection. It's got 3 flaps that hang down and cover the thigh, the groin, and the other thigh. And providing they're attached correctly, they do stay shut, while allowing you to walk. This one perhaps might have a hinge that has some slack in it sideways to allow it to rotate sideways, which again will probably be with a Kevlar hinge. Another big reason I'm wanting to use these Kevlar hinges is because if you can use that and you're not having to bolt on metal hinges, you're simplifying the manufacturing process massively, simplifying any failure points, and from a logistics point of view, it means you've got less stuff to carry to repair it. And back up to the arms again, they can go up, they can go pretty much all the way up if you want. You can go past that, that's now hitting that. And you can go out to the side, that's the idea with the pauldrons, you can still go out to the side while do having a lot of protection to them. To get into the arms, they will fold down on this ridge. The arms will likely be held out to get into it, and then they'll be latched shut at the top. The reason why there's no latches on it in a minute is the latches will likely have to stick out, because if you were to bury them into the armour, then you will create a weak point in the armour, because you'll have to reduce the amount of Kevlar and ceramic that you're going to put into it. The slight issue I'm having at the minute with this as a mock-up is that all of the foam can get pretty floppy. I've tried washing stuff out. That is why I've just taped these pauldrons here for this demonstration. But when they're actually made of the material intended, they won't have any of that slack in them. Moving down to the legs, this is something I'm very pleased with the shape. You have the shins that come out at the top, allowing the legs to go straight, and they are very thick as well, allowing for a good kneel point. In some places, these may be more than 30mm thick on the front, so if you're in a 1 knee down firing position, this would create greater protection here. And in said 1 knee firing position, that will rise above and help protect any gaps created here, so you do have to have more coverage in that position. What I realised is they do have to flare out at the bottom to give you enough room for the boots. That way you can have enough room for some side-to-side movement as well as up and down, and providing as much protection as possible at the bottom. You'll also notice quite a lot of flare at the back. That is 1, to make room for the boot that's going to go up and down inside, but 2, because there'll no doubt be some spring system or hopefully just elastic tacked as an Achilles heel, so that way there doesn't need to be another motor, and if it's elastic then you're not worried about any metal that could potentially break and cause damage to the wearer. To put these on, again, it'll all stay as one piece. However, for now, I do have to take the legs off to get them on. This is because the way the original knee braces were designed, you would put the exoskeleton over the top of the thigh. So to put these on in future, the shin will fold out and the thigh will fold out. The boot itself will then fold forward and allow you to get in. The boots are still on the same spring system. I will be getting rid of the spring on the heel. I found them to be pretty much useless. It will just be a spongy block of rubber, possibly in a slight semicircle with some grips on them. I think that'll do for the heel. I don't think you need anything else. However, there will still be springs on the front half of the boots to aid with any obstacles on the floor that you might step on, while providing a bit more spring in your foot, bearing in mind it's not going to be a light suit. And coming in from the side, we can see the joints where the motors will be mounted. I have on order a motor to try. I have wrote some code for the sensor system. That is all working correctly, which hopefully I'll be able to show at some point soon. The motor will go to the center of there. All of the hinge on each part will have its own sensor system in and will essentially be a modular unit that could be changed out if it's damaged or upgraded. But the bonus of that as well is the electronics will basically be in one piece. I'll get a trial electronics out now to show you. Here is my electronic setup, my prototype for it. I just use a stepper motor. Yes, a stepper motor wouldn't work. You can't really get them light enough, small enough, or powerful and fast enough. But it did work as a trial piece. You can see where the sensors fit from where the plugs are. It does work correctly. It does perform as it should do, and I am 100% confident it will work. I've been able to try it out by hand by physically moving it. The issue really with this test vehicle is the stepper motor, because there's just not enough torque when you try to run them fast, which turns out these do need to be run pretty fast. I believe I worked it out at around, you need to have a maximum speed of around like 150 RPM, which for a stepper motor is just pushing it really. Especially when you need high torque at that 150 RPM. If you want me to explain properly how this works, let me know in the comments down below, and I'll try to do a video on exactly how it works and how it works in line with the suit and why it will work when it is fitted. And back up to the mock-up armour. So you will obviously notice these gaps where the motors will go. What I intend on doing is having a cover that goes over the top of the motor. That is probably bolted on. That way it can be just removed, the motor can then be accessed. You can then use bigger or smaller covers depending on what you're wanting, and also depending on how much air currents you need to go through it to cool the motors, because that will be a consideration, I have no doubt. This also allows the actual armour pieces all the way down through the legs to actually be part of the structure, because then it means you don't have to take them off just to get to the motors. You'll actually be able to take the whole hinge system off separate and leave the armour where it is. The backpack is the least finished thing, even in design concept. But the idea is you would have the batteries in the middle, any electronics above or below it. You could have some cooling fans coming from the top down. The bottom half would be covered in moly. That way you can attach anything to it you wish. The angles of the backpack are by accident. The idea is if you're going through a doorway, you're probably going to have to go through sideways, so you wouldn't want a squared off backpack, thereby increasing your size even as you are walking through sideways. Furthermore, the idea of it being so tall at the back is because it will provide more protection to the neck and the back at the top, which will always be a point that is likely to have a bit less armour, a bit less protection, because you are going to want to be able to lean your head back. And that brings us back to the helmets, which these are two of, I think, 5 that I've made in total. So this was an early one, quite an original one. And the idea was with this one, you would be able to make it with just one mould and everything would be contained inside it. Nothing would be removed. It'd be very integral. There would be breathing ports coming out this way backwards. The Mohawk would have air holes at the top, again facing backwards to allow some heat out. And you would likely have quite an array of interior screens with cameras on the outside, so you can see more without having bigger eye ports. However, I decided that was too integral. It also feels absolutely massive when it's on, even though it's not far off the size it should actually be. There would also then be difficulty integrating earphones into the side of it. Also, these helmets aren't going to be light, so it will have a spine support at the back, basically a mini spine that I showed in the previous videos. But because it's fully integrated, all of that will have to be on the inside, which very much limits you, and it just limits you on ability to develop it further. Which brings us to the final helmet that I'm pretty sure will be the one to get made fully in composite. This has been based, as you can probably tell, off a ancient Greece helmet. I believe you call it a Cretia helmet, but I could be wrong. basically the type of thing that's on 300. I did find a really good cosplay video on YouTube with some templates that came through for ancient Greek helmets that allowed me to make the base so it actually fit over my head correctly, and then increase the thickness to arrive at the armour thickness that I require. Good features of this helmet are that it is designed to be worn so you basically have your chin down and you look up slightly as you're advancing. That reduces any gap around the chin. Also, that means for any screens inside, there only has to be one decent sized screen around each eye port, with of course a corresponding camera to each. There doesn't need to be one above, which there was kind of looking like on that helmet there would need to be one. You also have this mouthpiece, which is inset slightly by design. The idea of that is inset fully, it provides full protection. However, if you want better breathing, it will be on a slide, a notch slide even, so that it will be able to stay out slightly so you can have a gap all the way around. The piece also has tapered angles, so it means that when it is out slightly, there is no actual physical forward gap for any debris shrapnel rounds to get through. Also, with the angle it's at, even if a round did sneak down the side, it is likely to just go through the other side of the helmet or go down and out. While none of that would be a guarantee, it's certainly good to try input these design choices now. On to hearing, this is something that I couldn't decide on the old helmet what to do. So on this one, I decided to have earpieces that will come out, either slide out, possibly held by magnets or even hinge, or just be in by Velcro. That could work, as long as there is a stop to stop them going in too far. These are of course thicker, so you'd have the electronics and then hearing and padding on the inside, while still maintaining around 30mm of armour thickness. And of course, if these did stop working, if there was any difficulty like this, you can take these out then. This type of thing is a reason why full face helmets aren't used in general, because at the end of the day, you always want to be able to communicate with people. So if you have a completely closed full face helmet, that means if communication stopped working or whatever else, which I'm sure they will do, then you do have a backup. Because I did forget to mention, this piece, while it will come out forward, it will also come off completely, giving access to your mouth while still providing a lot of protection. The mohawk that runs over the top, again, is for purpose, it is for cooling. So you will have holes running that way through. That way there's no chance of any shrapnel or anything else going in from the front. There'll be no entrance hole at the front. It'll all be air circulation holes from the back. Dropping down to the rear of the helmet. This does work as a really good mounting point for the spine. This could be cut into at the bottom here. That way you're not sacrificing any armour design. This could, for example, not have any ceramic in here, which will be fine. As with the backpack, there'll never be a point where this is completely unprotected. That allows a really good mounting point for the spine. Also, with the thickness of the mohawk, particularly at the back, there's obviously going to be less need for cooling right at the back. This could have batteries in here to run the electronics for the helmet. As for electronics in general, they'll have to be battery powered in this. That way it will be easy to remove. You don't have to have a plug on it. Wireless charging could potentially work, but it's also not efficient on an energy transfer basis. You'll lose, I think it's like 30 to 40% of your power during wireless charging. However, there will probably be a plug on it, so it could be plugged into the suit's battery source to recharge the batteries in the helmet without having an external power source. This helmet as well should allow for slightly thicker armour in the forehead region, so you should be able to have more like 40, maybe even 50mm of armour there. Another design feature that I like and I try to put in is when it comes to making this helmet, how can you make it bigger? Width will always be an issue because a lot would change to make it wider. However, making it wider probably isn't that important. However, making it deeper, whether that's for more electronics, more of armour up front, different position at the back, or in general to make it fit the wearer better, What I'll be able to do is have a seam line down the mould, as it will be a split mould in 3 pieces. So you'll have a front half, you'll have 2 sides, and the split line for the sides will be along this line down here. That means if I desire this helmet to be, say, 10, 20 millimeters deeper, I'll be able to just add a spacer in between the moulds and create a bigger helmet. I hope you can see there has been quite a lot of thought put into these, into both of them, even though I'm pretty sure this is going to be the winner. So it's not just some copy of some sci-fi design or ancient Greek helmet, even if it does look like some sci-fi helmets. Turns out a lot of sci-fi writers, artists do a very good job. The last thing I want to touch on is anyone who's made molds before are probably looking at these and thinking this is far too rough to be made into composite material molds. It'll always look rough, you'll never get it out. And to a degree, that is correct. These are never going to be perfect. The first prototype that I make is never going to be perfect. It's never going to be absolutely smooth when it comes out of the mold. But I'm fine with that because it speeds up the process, which I've already been delayed on quite a bit. But then if I want to make more after, I'll be able to make a more perfect mold out of the prototype helmet that I'll get out of it and out of the other prototype armour pieces that I will get out of this design. But to redo it all, following the design that I've got, it would take weeks, months to make them perfect, cost more money, that just in the end doesn't really matter. I know I've done a lot of talking already, tried to get through it all as fast as I can. Now I'll get on to actually putting the suit on and show some movement in it and how it'll work. This is the first time trying on the full suit, got help putting it on by a friend. Used an airsoft gun to simulate how it'd be shouldered against the chest plate. It wouldn't actually go against the shoulder, it more goes a bit closer to the centre of the chest than normal. Here you can see the movement of the pauldrons, it all works pretty well. The pauldrons did get cut down because I realised while they do look good and provide more coverage, you can't actually get through a doorway with them that large. You'll also notice this is with the first helmet, which doesn't actually look too large on this video, but it's actually because the pauldrons are that large they make the helmet look smaller. Good movement all around. The noise you can hear is actually just the soles of the boots, but I can't wait to get done properly. Weirdly enough, in September in the UK we actually have a moderately bright day, which is shining enough light into my garage so I can actually try it on and film it. So I've got the legs separated that I'll be putting on a chair, and then when I've got those on, I will be able to use this jerry rig set up with an engine crane to put the torso on, similar to how I did in previous videos. This is with the newer helmet and the pauldron alterations. The whole process will be much easier when there's also less Velcro straps. All the Velcro straps are still needed because it is made out of foam. Also worth noting, if I look a bit like Bambi when I'm wearing these leg parts, it's basically because the soles have no grip on them whatsoever, so it's kind of like ice skating on the concrete. Onto the torso, I did realise after trying to put it on once that I need to do the arms first instead of put the chest piece on because you can't cross your arms that well. That's just a way to put it on. Once it's on, it's fine. That problem might actually go away once it's made out of the proper materials that it should be made from. So, I've just about got this armour on by myself. There are a couple of bits that aren't fastened down, and that's just because the points are too thin and I haven't been able to put the big latches that will be on the armour so you can just latch it on. So for example, the chest plate, the mechanism that came with the last time still works, but it's very fine, so really need 2 people to do it. And as I've tried to do it myself, I haven't been able to get it off. Along with the hip joint, even though in the previous clips you will notice that all of this was attached and all worked fine. So already I have made the pauldrons smaller so they come more in line, so you can get some doorways with it. And I realise this armour is way overly chunky in every manner. However, when I come to make the moulds out of them, I'll be able to trim the pieces down to fit there. But if I make them smaller, then want to make them bigger, I can't really do that, but I can always cut them down. So that's why it's way over chunky than it could possibly ever be. Stuff that works particularly well, despite looking extremely chunky, is actually the legs. And the feet work alright apart from the soles, which I still haven't done yet. Haven't done the soles yet because you need to know the weight of the suit so you can work out the correct surface area for the soles so you don't sink in mud, etc. With these modifications you can see how it's narrower in general. You can also, with me wearing it, see why the backpack being so high and the neck covers on the pauldrons being present is actually important for the coverage. And again, we have the airsoft gun over it. And an airsoft pistol, again, like fake, not real, just to show how you can bring your hands together in the middle in a bladed stance, I believe it's called. So, to summarise, the suit is finally getting to somewhere near the vision that I have in my head. The legs in particular feel good, and the overall fit is good once it's on. However, it is incredibly stressful trying to put it on, mainly because the tensile strength of gaffer tape isn't quite up to the task, but it is all like that so that it can be taken apart and used for moulds easier. I'd have liked to get more footage for you of moving around and doing stuff, but one, it's now not something that is easy to take somewhere, and two, on the second fitment I was on my own, so I couldn't do that much with it. The helmet I'm pleased with, but I think what I will do is I will shave the mohawk down a bit. I don't think it needs to be that tall, and then eventually when it is pulled out of the moulds, the chin will likely want shaving off. But again, in case I get it wrong and when I can't judge it properly with it being made out of foam and held together with gaff tape, there's no point in cutting this down yet. That's another reason why I'm glad when I have it made out of the actual materials it's going to be made out of, because then I can have it stood up properly and supported properly, most likely on the backpack, instead of having it cable tied up to an engine crane. Not ideal. Right, now it's better secured with cable ties. And crucially for the arms, I still want to try and thin the inside of the arms down so you can hold them close to you with less issue. They're not actually bad as they are, it's just they could be better. As to what I'll start with for the moulds, I think I'll either start with the helmet or I will start with the legs, because it's a part that I'm most happy with, and even if they do look bulky with a flare, they actually fit and work real well. As for what's next in this little video series, hopefully in the next video with the full suit where it's actually made out of the correct materials, I'll be able to do a less haphazard video showing more of its capability and how well you can still move in it, and in general it will look a lot more finished and like an actual finished prototype product. The motor I've ordered should be turning up around this week, so hopefully when it does I'll be able to then actually hook it up to a hinge and get the sensors working with that motor and prove that design concept, which I'm sure will work. So I apologise if this video was slightly lacking in action, but I want to do an update regardless, and that also allows me to get on to the next part of it, which is breaking it all down for the moulds. I'll try and leave you with some stills of the suit, so thanks for watching. Like and subscribe if you like to. I also do some other videos on model kits and smaller stuff, and there's the rest of this series to go, and things will only get more interesting to watch in the future on this power armour suit.